So my dear friends, our real number chapter is full of theorems. I saw that theorem number 1, chapter number 1, that is 1.1 was Euclid's division lemma. This is what the theorem is. Then we saw theorem number 2, that is 1.2. Do you recollect? Yes, it is fundamental theorem of arithmetic, FT as I say, prime factorization method. Then I have seen theorem number 3, that is 1.3. What was that? It is based on prime number, right? If P divides A square, then P divides A also. Similarly, I have now this section is all about theorem number 4, that is 1.4, and this is so simple. Root 2 is irrational. Very simple statement. Let's see कि proof भी इतना simple है जितना simple इतना इसका statement है. Let's see. So root 2 is irrational. The proof goes like this. I say I just oppose this. मैं बोलता हूं कि नहीं, root 2 irrational नहीं है. It is not irrational. So I assume that root 2 is what? Rational number. So if it is rational number, then root 2 has to be what? P by Q. For example, if I say this is 14 by 10, that means 7 2s are 14, 5 2s are 10, which is 7 by 5. That means in our second step I can see that root 2 is P by Q and P by Q is AK upon BK. What is AK? AK is 7 into 2, K is 2, and BK is 5 into 2, K is 2. So this is AK upon BK. If I cancel KK, as I have cancelled here 2, then I get root 2 equal to A by B. So that is A into 1, B into 1. So what is the common factor between this A and B? The common factor between A and B is 1. This is step number 2. Now, after having understood this fact, I know very well that root 2, that is step number 3, root 2 is A by B, therefore A is equal to root 2B. Now, if I square it up like this, that means A square will be equal to 2B square, and therefore A square is divisible by 2 as per that theorem number 1.3, prime divisibility of prime numbers theorem. So I have A square by 2, that means A gets divided by 2, therefore A by 2 is a fresh constant, fresh integer, that is C, therefore A equal to 2C. Remember, I box up this statement, that is A equal to 2C, right? Now I have A is equal to 2C. Now what I will be doing is I will come to step number 4. In the step number 4, I bring this A is equal to 2C over here, and step 4 में इसका square करेंगे. Therefore A square will be is equal to 2C का whole square. Agreed? But if you recollect in our step number 3, in step number 3, as I can see, A square was 2B square. And here A square is 2C ka square. So I bring this A square ke jagah 2B square and I put it over here. I replace A square by 2B square. So this becomes my step number 5. In step number 5, therefore we have 2B square equal to 4C square, and therefore we can see that B square equal to, yes, 2C square. So in the similar manner as we did earlier, therefore B square gets divided by 2 and B is also divided by 2. Therefore B by 2 is equal to a fresh integer D. Therefore B equal to 2D. Now this B equal to 2D I have, and earlier I had, if you recollect, A is equal to 2C. So I have two things now. In step number 6, I can see here I have A equal to 2C, and here I have B equal to 2D. In both of them, 2 is the common factor because this is 2 into C and 2 into D. If 2 is the common factor, what was our assumption, if you recollect? That the common factor between A and B is 1, whereas the common factor between these two is 2. Therefore, our assumption is wrong. Therefore, root 2 is not a rational number, and therefore the proof says that root 2 is irrational number is getting proved by this method of contradiction.